All right. Good afternoon, everyone. Thank you for joining for the record live session, the impact of new ozone and PM2.5 significant impact levels on your PSD projects. Before we begin with the live session, a few logistical instruction. The presentation will be for 45 minutes, and we will follow up that with a Q&A and discussion session for 15 minutes. For the duration of the presentation, all attendees will be kept on mute. If you have any questions, feel free to use the question box in the GoToMeeting panel to send the questions to us, and we will try to respond to those questions during the Q&A session. You can also ask questions when we open up the lines during the last 15 minutes. And lastly, if you have any follow-up questions after the webinar is done or we run out of time to answer all the questions, you can always follow up at the email address given in the presentation. Following the presentation, sometime early next week, we are going to send you guys an email which will have instructions and a copy of presentation. And then the instructions will be provided to see the recording of this webinar if in case you missed something. So with that, we're going to go ahead and start the presentation. My name is Abhishek Bhatt. I'm a technical manager at All4's Houston office. I have over 8 years of academic and consulting experience doing dispersion modeling. My specialty includes a regular PSD NSR, dispersion modeling, risk assessment, and also CAMEX and CMAC for a clinical model.
Thanks, Abhishek. My name is Dan Dix. I'm also a technical manager with All4. I work out of our All4 Philadelphia office. I've been with All4 for 14 years now, and likewise, my expertise is in air dispersion modeling, and also I focus on ambient pollutant and meteorological monitoring as well. A little bit of an introduction to All4. We really specialize in air quality consulting and provide support in 7 key service areas. One of those 7 key service areas is air quality modeling, which is what we're here to talk about today. And we really focus in on complex facilities in heavy regulated industries as well, and strive to come up with unique strategic solutions for modeling projects. And we've seen that this has been necessary with the stringent NAAQS, the 1-hour NAAQS, the PM2.5 NAAQS that are out there. And really to do this, All4 has a core group of air quality modelers, and we support a variety of support to regulatory and permitting programs. We're going to focus in today and talk about PSD permitting and the NAAQS modeling that goes along with that. Abhishek leads up our photochemical modeling side of things. We've assisted with SIP NAAQS modeling analysis, ERCs for non-obtainment new source review, A2RVs analyses, BART, state toxics, external release, and minor source air permitting. And to do this, All4's team is really experts in all the various air dispersion models that support these regulatory and permitting programs. So with that, get started on an overview of this live session. First, we're going to talk about the background of PSD modeling, a little bit of when you're required to do modeling under PSD permitting, and the role that the significant impact levels play in that process. We'll then go into the proposed ozone and PM2.5 SIL guidance, which we're here to hear about today, those ozone and SIL values. Abhishek's going to talk about the methodology that EPA evaluated to come up with these proposed values. And then we'll walk through the implementation and the timeline associated with this guidance. Then we're going to get into, and I think this is going to be advantageous for folks on the phone, is some case studies on how these new SIL values could potentially affect PSD projects. I'll talk about a case study related to the PM2.5 proposed SILs, and Abhishek's going to talk about the new ozone SILs. And really going through some case studies and talking about how this may or may not affect my PSD project. For those not in the weeds every day in the air quality modeling lingo, just setting this up for folks, significant impact rates or emission rates, these are the PSD thresholds that then require a air quality modeling demonstration. Significant impact levels, That's what we're here to talk about today, the SILs. Prevention of sediment deterioration is the permitting program that then requires a modeling analysis and the use of the SILs. For us non-modelers, the SILs are in the form of the maximum first highest impact. We refer to that in the modeling world as H1H, or high first high. This is the form of the standard. Think of the NAAQS, for example. The SO2 NAAQS is a 98th percentile 98th percentile value. That's a fourth high value. Then we'll talk about or tons per year when we're referring to emission rates. A little bit of background. I'm sure most of us have been somewhat involved in a PSD project. Essentially, there are thresholds out there, whether you're a new major source or a major existing or minor source. And I think most of us involved here have been a existing major source. So the critical PSD significant emission rates for ozone are the ozone precursors, VOC and NO2, which is 40 tons per year. And then for PM2.5, we're talking about for direct PM10, 10 tons per year, and for PM2.5 precursors, SO2 and NO2, 40 tons per year. So for a existing major source, if you have a project, if project-related emissions are greater than these thresholds, that then on the PSD permitting program trips the requirement to do a back analysis and also to do a modeling analysis. Here's a flow chart of that modeling analysis, and it's really a two-step process. And the first step is evaluating your project-related impacts and their effects and comparisons to the SILs. If you can demonstrate that your impacts are less than the SILs, then you've satisfied your requirement. There's also an additional requirement based on the remanded 2.5 SILs that came out of litigation between Sierra Club and EPA, that you also have to demonstrate that the difference between the background and the NAAQS is less than the SILs. That may change depending on this draft guidance, because there was information about this in the guidance that Abhishek will touch on. If you're greater than these SILs, then there's a requirement to go to step 2 and do a NAAQS analysis. And I'll point out that it's pollutant specific and averaging period specific. So for example, for PM2.5, we have an annual NAAQS and we have a 24-hour NAAQS. If I am greater than the SIL for one but not the other, I only need to pass through and do one. The NAAQS analysis then is your cumulative impact analysis, where I need to bring in the rest of the unaffected sources at my facility, other background sources, and background concentrations. And what's important here really is the SIL does come back into play in this step 2 if, when you do cumulative impact analysis, you're greater than the NAAQS, then you can go and look at your facility's contribution at those exceedances, and if you're less than the SILs, then you're not culpable and you satisfied your requirements. So that's the second place where that SIL comes into place in this two-step modeling process. So as you saw from that flow diagram, the role of SIL, it's a good thing. That first step was a whole lot smaller than the second step there. And like I said, if you're less than the SIL, you've satisfied your modeling requirement under PSD. What that means for you is a significant reduction on the project timeline and a significant savings on resources to do that cumulative impact analysis. And what you're avoiding is that bigger step 2 block that you saw previously, that is the cumulative impact analysis. And you're also avoiding potential issues with that. And that's really been a strategic approach for us, is try to be below those SILs and not have to do cumulative impact analysis, because what happens is I'm bringing in local sources, I'm bringing in background concentration, my headroom is shrinking to a smaller and smaller level and leaving me less and less space. So it has been advantageous to ensure that you're below the SIL and don't need to do a cumulative impact analysis.
Now, some of you who are familiar with the MRFs might be wondering, what about MRFs? Where do they fill in? For those who are not aware of MRFs, MRF stands for Model Emissions Rates for Precursors. It's a new concept which was introduced by EPA as part of the Appendix W changes introduced last year. The way MRFs are anticipated to work, they are going to be another threshold or de minimis threshold values, which will fit between your SCR and SIL. So from the flow of PSD modeling point of view, if your project is greater than your significant emission rates, you will trigger PSD. Then you compare your modeling project emission rates to these MERPs, and then if your emission rates are below MERPs, then you don't even have to go into any kind of PSD modeling. Now, let me be very clear, these MERPs are only proposed for ozone and PM2.5 or secondary PM2.5. They are not, at this point, and I don't think so it's going to happen in future, the MERPs are not going to get proposed for all the other criteria pollutants. MERPs do have some advantage in the whole PSD role, because again, you don't even have to do that step 1 of significance analysis. So essentially you can avoid doing any type of modeling if your sources are small enough. However, and that's a big however, that right now, we don't know what will be the current form of the MERPs. We don't know what's the current status. EPA proposed the MERPs as a theory or as a concept in Appendix W changes, but haven't got out any guidance or any rulemaking to say what those values are going to be. Some of the critical things about MERPs includes, since ozone being a regional issue, are the MERPs going to be standard, or are the MERPs going to be regionally varying? So there's a lot of unknown, and clearly because of the way MERPs are going to be used, there will be a separate rulemaking which will be required in order to get them established in this flow chart. So there's a lot of uncertainty with MERPs, and also the timeline is not yet known. So in between now and when the MERPs are finalized, we are kind of stuck with going ahead with SIL and the SCR and SIL portion. So let's get to the meat of the bone. What are the proposed ozone and PM2.5 SILs? What is the guidance saying? So the best thing is we finally have the first ever ozone SIL for our 8-hour 70 ppb NACs, and that's set up at 1 ppb. Now, if you compare the SIL values of the temporary or intermediate SIL values for NO2 or SO2 and compare them to the NACs levels for NO2 and SO2, they are somewhere around 3 to 4% of the NACs values. Versus ozone SIL, the proposed ozone SIL is barely above 1% of the ppb NACs value. So upfront, out of the gate, we can know that this specific NACs SIL value for ozone is significantly conservative. In addition to the ozone SIL, EPA's guidance also came up with the revised PM2.5 24-hour and PM2.5 annual SILs. The PM2.5 24-hour SIL used to be 1.3 micrograms per meter cube. They ratcheted it down to 1.2 micrograms per meter cube. I'm sorry, it used to be 1.2 micrograms per meter cube, and even though EPA's methodology derived it to be a 1.3 micrograms per meter cube, EPA decided that because 1.2 is more conservative value and it is in the rulemaking right now, we're going to go ahead with 1.2 micrograms per meter cube. So right there, EPA is kind of confusing, because they're like, we have this awesome methodology which can derive really good SIL values, and we think that awesome methodology gives out 1.3 micrograms per meter cube, but we're not going to go with 1.3, and still going to stick with 1.2. What makes it more interesting is that when it came to PM2.5 annual value, the current annual value was 0.3 micrograms per meter cube. So when the derived value came out to be 0.2 micrograms per meter cube, they pretty much did a 180-degree flip and said, well, now even though there's a 0.3 micrograms per meter cube in the rule, because this awesome methodology we have is saying 0.2 micrograms, we're going to revise it to the 0.2 micrograms per meter cube. So they are not being consistent, but well, they're EPA, so it's obviously they're trying to be conservative. The good thing about the guidance, the way it is laid out, is that if the permitting authorities, the state agencies, or EPA eventually decides to go ahead with these SIL values, you will not have to do any additional justification to use these values. And what EPA is anticipating, that all the justification has been already done by the means of that EPA, by the methodology they have used to derive these values. So that's a good thing. That's one additional step which was introduced as part of the PM2.5 modeling guidance, which again now gonna disappear. So that's a good thing for industry, that you don't have to put those additional resources in. Now look at what the EPA's methodology was. So EPA relied on statistical significance or existing statistical framework, and their approach was to use air quality variability, and they used the bootstrapping method. In layman's term, they looked at the monitoring data for a time period, looked at each hour's monitoring value, and looked at what will be the variation in the monitoring value if nothing else changed in the background. So if you don't have lot many sources being added or lot many sources being removed, if there's not much changing in the background contributing to that monitor, what is monitor's natural tendency of reading the values or of monitored values, and what are its bounds? And when they decided that, okay, this is the natural variability, then they looked at the smallest bound, and what they are saying is if this is the smallest bound, which even if you don't change anything, monitoring values are going to fluctuate within these small values. And then they further ratcheted it down, saying that let's just take 50% of that small bound and say that if somebody, some facility wants to increase emissions, and that's going to impact that monitor, if that impact is within the noise of the monitoring value or the smaller bounds, then that's insignificant, because even if you don't have that source present, the monitor is still going to show that fluctuation. So statistically, it's a very good solid analysis. However, just because a statistical model proves something, that doesn't mean it's practically going to be possible. Statistically, I can pretty much potentially do some analysis and prove I can grow mango on an orange tree, but practically that's not going to be possible. So there is that argument to be made that whether that noise, statistically calculated noise, is that truly a noise, and then significantly ratcheting it down, does that really makes it insignificant? So that's something which we will have to evaluate. The other part of the guidance, which is kind of open-ended, is the whole implementation and the timeline. The way EPA has defined this guidance is they're saying this as a non-binding guidance, and they are leaving complete discretion on the permitting authorities to consider this guidance. So that's a different step which they have taken from the past, where the SILs were, for PM2.5, the SILs were actually codified or made written into a rule, which was a binding agreement or binding guidance. Their justification or argument is that the permitting authorities can use the SIL values without any justification. So if your agency, if a state agency wants to just take this guidance as a gospel and just apply that, then that's good. We're not going to challenge that. However, if permitting authorities want, they can actually take this guidance and derive their own SIL values. And in that case, they will have to provide additional justification. And they also give permitting authority a third option, that they can elect not to use this value, the SIL values at all, and the state, I mean, it can be a status quo as is. They are saying that they're gonna entertain comments on this draft guidance till September 30th. However, since this is not going to be a rulemaking, and this is a draft guidance which EPA is asking comments on, it's not clear what will be the timeline of a final guidance being released. If any past such guidances are indication, I can bet my money that there won't be any final guidance coming anytime soon. We still are using many draft guidances from the past. So it looks like that EPA's idea is that they're going to let the permitting authorities select this option, and then they're going to just observe that, and they lay out that plan. So first of all, just for those who might be confused what the permitting authorities or who the permitting authorities are, state agencies for the states where the SIP approved PSD program is there. States like Texas, Pennsylvania, who have the deferred delegation of the PSD program, the state agencies will be your permitting authorities. So immediately the state agencies will have to make the decision whether to implement that, implement this guidance or not in their modeling guidance. And this is where it kind of gets convoluted in terms of timeline, because what if EPA never comes out with a final guidance? What do the states do? Do they just take this draft guidance and implement the draft guidance in its current form, or wait for EPA to set up the final guidance? So there's that missing portion about the timeline. For the states, without any SIP-approved PSD program or delegation of the PSD program, EPA regional offices will be your permitting authority. So if your facility is in those few states, then you can start preparing that these guidelines might be implemented, since this is EPA's program. Now, the EPA is being careful about not coming up with a ruling based on what they had to go through with the PM2.5 SIL ruling. So what their plan is to, again, as I said, come up with this as a non-binding guidance, let state authorities or state agencies or permitting authorities decide whether or not to implement this, so they gain an experience gain an experience and information on how exactly the state agencies are dealing with this. And also for the state agencies who are applying these guidance in future, they can gain more experience about how exactly those are being applied, what are different industries and permit applicants are doing in terms of obliging with these guidance rules or obliging with the SIL values. And what they are assessing is that once EPA gathers all this information from different states and different permit applications, they can then revise this guidance and eventually codify this to make it potentially a binding rulemaking. EPA was very clear that currently they do not have any rulemaking plans in near future. So you can anticipate that Ozone and PM2.5 SIL will stay in this guidance format for at least for near future, and whatever that means for EPA's timeline, near future. But so that's kind of is the implementation and the timeline portion of it.
Thanks, Abhishek. So we're going to into a couple sample projects here in case studies to see how these new SIL values could potentially affect PSD projects. So first sample project I'll go through here, part of the PSD permitting program, looking at a new natural gas fire power plant, 2-on-1 configuration, relatively tall stacks, 225-foot stacks, and then some ancillary equipment, a natural gas fire auxiliary boiler, cooling tower, heaters, emergency generator. In this example, it's natural gas fired, but there was a capability to fire ultra-low sulfur diesel as a backup fuel. Looking at air mod results in this case, this particular case it was in an area that had complex terrain. So what that means is there's elevations surrounding the facility that are higher than stack top, higher than that 225 feet there. 5 years of National Weather Service meteorological data, which is pretty typical. Also typical of a lot of these new natural gas fire power plants, a relatively small ambient air boundary. And for non-modelers, an ambient boundary, essentially, if I can restrict access to the public, then I don't need to evaluate receptors or concentrations on my property. And in this case, the distance from sources to that boundary was relatively small. So here are the results of that analysis summarized above. For the 24-hour PM2.5 SIL, because of the use of ultra-low sulfur diesel as a backup fuel, we were in exceedance of the proposed SIL, and we would have been in exceedance of, well, in this case, the proposed SIL and the derived SIL as well, the 1.2 or 1.3. For the annual standard, you'll see that for NAAQS, we came in at 0.29, 0.28 for the NAAQS and the PSD increment. So this is a case where with the existing SIL of 0.3, we were less than it, and we didn't need to do any further analysis. With this new proposed SIL, this potentially brings us into needing to do a NAAQS analysis. And really looking into how the results for fleshed out, the impacts were mostly due to the cooling towers and that relatively short distance from the exhaust points in the cooling towers to the ambient air boundary. Also, under the PSD programming, we're evaluating increments as well, Class 2 and Class 1 increment. In this particular case, the Class 1 increment annual is being slightly reduced from what the historic value is, but in both cases we were able to demonstrate that we were below that threshold. I'll point out that some of us have been involved. There's not really a standard approach for evaluating Class 1 areas beyond 50 kilometers. AirMod's quote-unquote limitation is 50 kilometers, so in this case we conservatively modeled at 50 kilometers and took that concentration and applied it to Class 1 areas 150 kilometers away. For the 24-hour standard, we've had to use a little bit less conservative approach and extrapolate values just by developing a trend line with AirMod concentrations to 50 and extrapolate that out to Class 1 areas. Again, the second step in this process is, at least for the annual, I'm able to demonstrate that I'm less than the SIL, but then I also need to show that the difference between the monitored concentration in the NACs is greater than that SIL. So in this particular case, 12 is the NAC's annual concentration, 11.6 was the background. So that is greater than the proposed SIL of 0.2, so that justifies its use. But you can see, essentially, this is the headroom test. I am starting off with 0.4 micrograms of available space. Now, I demonstrated that I was at 0.29 from the facility, but we also have to bring in all the local sources, and that's where that next step 2 could present issues when we go into the cumulative impact analysis. Switching over to a second sample project. In some states, there's requirements to do SIL and NACS modeling for minor source permitting. For this sample project, we're looking at a state that requires a SIL analysis for projects that are 50% of the SIR for PM2.5. And in this particular example, we're looking at a pulp and paper mill that was interested in adding a precipitated calcium carbonate plant, and then we're going to reroute a portion of their existing lime kiln exhaust to that new PCC plant. So again, the first step in the analysis is evaluating the project-related impacts for comparison to the SIL. So the project-related impacts were the lime kiln because of the rerouting, and then the new PCC plant. Relatively low PM2.5 emission rates, but focus in on that PCC plant stack height of 190 feet, which those in the pulp and paper industry might think is a little, higher than normal. So in this analysis, again, AirMod, a little bit different terrain associated with the site, simple terrain, so no elevations above stack top, still using 5 years of National Weather Service data. In this instance, we had a relatively large ambient air boundary, a good distance from those stacks to where we're modeling concentrations. So here's the results of the 24-hour and the annual. You'll see in both instances, we were able to be less than the SIL, so we're done. We satisfied our modeling requirement under this minor source permitting requirement. But what I'll point out is, in order to get to that 1.2 level, we evaluated different stack heights of that PCC plant. It was more advantageous to design the new PCC plant to ensure that we were below the SIL because of project timing and because of the uncertainties around doing that NACS analysis. So here's an example where, well, we're pretty close here, and that 1.2 versus 1.3 or 0.2 versus 0.3 could dictate how we're designing facilities if we're strategically trying to stay under those SIL values.
All right, now we're in the last stretch, the ozone SILs. So because ozone SIL is a new thing, we didn't have a sample project, so we decided to go and do some case study analysis. So we looked at potentially developing 3 hypothetical PSD projects. The 3 projects can be a representative of, so in terms of buildings, footprints, and type of sources, we decided to look at different plants. So you can think about one is an NGCC, or the natural gas combined cycle. One is a pulp and paper mill, and another one is a cement plant. So we kind of cooked up a dummy project with buildings and sources, representative of that. In terms of emission rates, because we were trying to evaluate how the emission rates are impacting the SIL, instead of actually going with a project representative emission rates, we decided let's look at how the SIL will fare against the SCRs, or the significant emission rates. So 0.5 times SCR is the half of the SCR. Now, even though you don't have to do any analysis because you're not triggering PSD, it's just interesting to see how SILs and SCR kind of interact. So that's why we decided to go with 0.5 SCR, and then emission rates equivalent of SCR, 2 times SCR and 3 times SCR. Now, for existing major source, making some major source modifications which triggering PSD, these values are kind of reasonable in terms of what the project emission rates will look like. But for a greenfield facility, or for a kind of a brownfield facility with complete overhaul, these project emissions may look really small, or might be a little smaller on a smaller edge. So, but still, it will give you kind of a good idea. From source perspective, we decided to go ahead with 5 or 4 example stacks. We decided to, rather than kind of using 125 feet or some weird numbers, let's just go with 100, 200, 300, and 400. And then in terms of stack temperature, stack velocity, and stack diameter, we looked at some of the combustion and process sources like auxiliary boiler, reheaters, thermal oxidizers, and coaters, which are again kind of representative and common sources at some of the facilities I mentioned earlier, and obtain the stack temperature, velocities, and diameter from those type of sources. So how did we completed this analysis? One of the biggest thing right now is there's no single source ozone model available. It's been a long-standing request both by modeling community as well as environmentalists to EPA to come up with a single source ozone model. EPA in its Appendix W updates kind of came up with 3-step analysis to handle ozone modeling. Due to chemistry involved in ozone formation, AirMod is not an appropriate model to be used. However, for past few decades of the past decade, the AirMod is kind of used in the pseudo-quantitative way through ratio method, and ratio method is basically what was derived through the ECMA curves. But essentially, you use AirMod, you model your NOx or NO2 NOx emissions, and calculate maximum NO2 concentration at 10-kilometer radius circle. You assume full NOx to NO2 conversion, so you don't use PVMRM, OLM, or any of those tiered analysis for NOx. You just assume it's 100% conversion. Once you obtain those NOx, NO2 concentrations for first high, you convert that from micrograms per meter cube to ppm, and then determine your ozone concentration by assuming that 90% of that NO2, as the plume reaches that 10-kilometer mark, is going to get converted into ozone. And then the conversion ratio, depending on where your facility is located, that conversion ratio can be 1 mole of NO2 producing 3 moles of ozone, or 1:5 mole of ozone. So you use that methodology. There is a lot of conservatism built in, but in lieu of any other actual ozone chemistry preferred model, this method was good enough for some of the state agencies to accept the results from. So for this specific case study, we use that analysis. So first, look at results from Michigan. Looks like the results were kind of fared pretty good. Only a small stack, the 100-feet stack, was something which was exceeding your SIL value. The SIL value is set up at 1 ppb. You can see that black line. So for all different emission rate categories, only your 100-foot stack project was exceeding the SIL. Now, unfortunately, once you exceed one source, you have to go through the cumulative analysis. So if you had a facility where all 4 sources were there, you still had to go ahead and completed the full impact analysis. But if you had only one source which was triggering PSD, then you kind of are okay if you have a higher stack, which goes back to what Dan was saying, that they had to play for that sample project number 2, we had to play around with the stack height in order to stay below the SIL. Now, what's in addition to just kind of saying that, well, the stack height, changing in the stack height and stack parameters may get you below the SIL, in case you cannot really do that, the other alarming thing in this situation is that if you look at the SER, 1 times SER value for a 100-foot stack, the impact from your source only is close to 4 ppb. Now, if you're looking at monitoring values, the current monitoring values at some of the Eastern monitors, ozone monitors, and compare that to the NAAQS value, you're looking at about 2 to 3 ppb headroom. And that headroom needs to be accommodated by not just your project emission increase, but from everybody else. And what that tells me is that if you happen to have a project which triggers triggers the SIL and full impact analysis, you're going to have issues passing your NAAQS analysis because your project impact itself is close to 4 ppb, which is itself is going to put you above the NAAQS value. Now, same set of sources, slightly different configuration of the facility, definitely different configuration of meteorology, and completely different configuration of the terrain. If you run that, you can see that now the impacts from all sources except kind of the highest stack of the 400-foot stack is getting really close or exceeding the 1 ppb SIL. Now, a couple of things. The variation is not only due to the location difference, but also due to the terrain height. So meteorology and terrain both are impacting that. And also, again, to caveat this, because we were trying to emulate different types of facilities, the building downwash configurations, the fence line configuration is also kind of impacting this. Again, the same observation, you have more sources which are going to exceed your SIL value, and in addition to that, the exceedance is high enough that in your full impact analysis, you will have some concern with passing the NAAQS values. This is, I believe, is the final one. This is kind of a pulp and paper facility representation. You have a kind of a smaller footprint. However, the footprint is not that of an issue since you are not looking at impacts close to the facility. You're just looking at impacts at the 10-kilometer circle. But if you go through that, you can see pretty much all the sources are now exceeding the SIL value, which again is indicating that even at 1 SER, even if you are barely triggering the PSD for NO2, you can potentially will have issues with this 1 ppb SIL, and will have to go through the full impact analysis. And even in that full impact analysis, you're looking at a few ppbs of impact just from your source, which will lead to having some issues with NAAQS demonstration also. So what's kind of the outcome? So first of all, again, I want to caveat that currently there's no EPA preferred recommended ozone SIL, one single source model, which makes this analysis difficult. So EPA has released the SIL values, but which basically says model your concentrations from your project and then compare that to these SIL values. The problem is there is no model to do that. So the SIL values in its current form are kind of like, well, what do we do with these values right now? In the meantime, when you don't have these preferred models, you have a couple of alternatives. The most favored alternative is this qualitative or / pseudo-quantitative methodology of ratio method. Now, because this is a pseudo-quantitative methodology, it's extremely conservative. And as you can see from the case studies we did, the SIL value itself is conservative, and on the top of that, this methodology is highly conservative, which basically means that regardless of what project emission rates you have, the chances are that these SIL values are not going to be useful, and you will potentially have to go through and do the full impact analysis. And then the biggest question which came to my mind when I ran these case studies is like, how will the MURPs will fit in? because if I have SCR, the idea of MERP is the MERP will be a value which is slightly higher than SCR, which if you run your project at those MERP values is not going to trigger the SIL, essentially having not needing any modeling values. But from the case studies, it looks like even at SCR or the SIR values, your sources are going to exceed SILs. So how do you define MERPs in that case? How do you define a value which is not going to impact more than SIL? So that's kind of is another question. And one of the other thing which again came to my mind is ozone is a highly regional phenomenon. The way ozone formation happens in Texas is completely different than the way it happens in Pennsylvania, and it's completely different than the way it happens out west. The ozone chemistry involved in it is completely different. So how is it fair to have a universal single cell value? Is that variation in geography and formation being evaluated in this noise or the air quality variability analysis? So those are some of the questions which were raised. So the other solution to this, what is EPA is trying to get to through the Appendix W, the proposed Appendix W, is the photochemical modeling analysis. The photochemical models such as CAMEX and CMAC have more advanced photochemistry. They generate more realistic results, and they incorporate not just your facility, but incorporates many sources, which makes it more realistic in terms of the actual comparison to the monitoring values. There is the concern that these sources can need more resources or may need additional time. But trust me, based on my experience of running these models, and that's why I have those question marks, and based on my experience, these models are getting, the model runs and the projects which we are doing are getting cheaper, that they can be compared to the SIL or full impact analysis. In fact, you can potentially spend more money on doing an NO2 NAAQS compliance than the ozone assessment. You can spend up to 100 grand to just go through the ozone, NO2 NAAQS compliance, whereas in 35 or 50 grand you can just get done with the ozone assessment. So that's why I have those question marks, that over the past few years the photochemical modeling analysis is getting cheaper. It's getting much more available for consultants and industries to do that. So how will the CAMEX fare against this SIL analysis? Now think about the SIL analysis which we did in the case studies. We didn't have enough time and resources to actually run the same case studies on CAMEX, but comparatively, our experience shows that we ran an expansion at a PSD expansion at an existing LNG facility. The expansion was about 2,000 tons of NOx emissions. When we ran the air mod ratio method analysis, we were looking at somewhere around 6 ppb of ozone concentration and now compare that to 1 ppb. There's no way we were going to be under the SIL. And also considering that the area was very close to non-attainment, we only had a couple of ppbs of headroom. There was no way we were going to even do the full impact analysis or pass at the full impact analysis level. So we ran CAMEX, and then the CAMEX showed that the project facility impact was about 0.9 ppb. So if we actually had SIL guidance at that time when we did that project, we would have been much more in better shape, that we could have just said we're below 1 ppb, we're good to go. Similarly, a couple of other projects, a greenfield cement plant, we were doing some fatal flaw analysis for them, roughly 500 tons per year of emission increases. When ran through the ratio analysis, was showing about 3 ppbs of emission increases. When ran through CAMEX, showed about 0.2 ppb. And then a small PSD expansion project at chemical plant, couple of hundred tons per year of emission increases, showed about 3 ppbs of ozone increase through air mod, and was about 0.6 ppb of ozone increase through CAMEX. So how does all presentation kind of tie in? So first of all, availability of SIL, especially for ozone, means that possibility of avoiding full impact analysis. So it's a really good thing in the long term. You can significantly save time and resources if your project can stay below the SIL values. However, based on the small case studies which we have done so far, the proposed SILs are very stringent, and demonstrating that your project is going to be below SIL is going to be very difficult. You can potentially will have to do some source characteristics analysis or to evaluate some stringent controls, like increasing the stack heights or adding higher controls. But however, if you can afford to do that, if your project can manage to do that, and if you can stay below the SIL, you will avoid a full impact analysis. Current techniques used to predict the ozone and secondary PM2.5 concentrations are not sufficient to tackle these stringent SIL values. So again, as we saw, ratio method, if we do not switch to a more refined or advanced models, ratio method is going to pretty much always going to give you a value impact above SIL, which makes SIL values pretty much moot, and you just avoid, you cannot avoid the NACS analysis or full impact analysis step. So you need to switch to advanced models. CAMEX and CMAC are the couple of models, which again, that's where EPA is also going through the proposed Appendix W. So with all this in mind, if you have future projects or PSD projects in your mind where you're going to have NOx or SO2 impacts increasing from SCRs or greater than SCRs, potentially plan ahead. Try and see how these guidance are going to impact your analysis. Try and do some fatal flaw analysis. Evaluate the background information in your facility, at your facility, both for ozone and PM2.5. See how much headroom do you have, because if you don't have much headroom, that itself can be a good indication for you that you need to stay below these SIL values, and that can dictate the timeline and also the budget for your projects. With that, final slide, that's my time to plug. What can we as an All4 do to help you guys? In immediate future, we are at the very moment evaluating and still going through the methodology given by EPA, and we are in a position, if you need to assist how exactly this guidance can affect your facility. We can also assist you in preparing the comments for this proposed guidance. As I said, we are evaluating the guidance, the methodology. We potentially intend to write our own comments if we strongly feel about something which we think we should provide to EPA. We can also assist you in coming future to do some fatal flaw analysis to see if your future PSD projects, how the future PSD projects are gonna get impacted by these SIL values, and how they will fare against these SIL values. As excuse me, as Dan mentioned, we have expert teams of modeling team who is experienced not only in PSD and NSR modeling projects, but also in photochemical modeling projects, and we can certainly assist you in doing the using the photochemical models for ozone and PM2.5, so that we can potentially get your projects below SIL. And also we have over 10 years, 15 years of experience interacting with agency, because eventually agency is going to be the ones who's going to decide how this if to apply this guidance for the PSD program or not. If they want to apply, then how they will be applying this guidance. So we will be more than happy to assist you to interact with them, to provide any comments you may have on that to the agency. And for all the agency folks out there, it's the same thing for you guys. If you All4 is in position to evaluate EPA's guidance and EPA's methodology, and kind of suggest you if you should, for your region or for your facility or for your region or for your state, if those values are accurate or not, or whether you should go ahead with some certain other values.